Welcome to the first screencast for Chapter 2. In this screencast we will start with some general chemistry. We'll briefly look at atoms, elements, isotopes, ions, and molecules. All things, both living and non-living, are made up of matter. This includes your body, the computer you're using, the air that you're breathing. These things have mass and they occupy space. All matter is composed of atoms. An atom is the smallest unit of an element that possesses all the characteristics of that element. Atoms of an element are not easily divisible by ordinary chemical means. Ordinary chemical means includes heating, cooling, treating with an acid or a base. Nuclear fission, splitting atoms like in an atomic bomb, is not ordinary chemical means. All atoms must contain at least one proton. Protons are relatively large, positively charged subatomic particles which are found in the center of the atom, in an area called the nucleus. Also usually present in the nucleus of an atom are one or more neutrons. As you might guess from the name, neutrons are neutral. They have no electrical charge. Surrounding the nucleus are one or more electrons. Electrons have a negative charge and are much, much smaller than protons or neutrons. Often the number of electrons equals the number of protons. Atoms are often depicted in a manner similar to this. Protons and neutrons are tightly packed in the center, called the nucleus. Electrons are arranged in orbitals or shells on the periphery of the atom. Elements are pure substances. By that we mean they're composed of only one type of atom. All atoms of the same element must have the same number of protons in the nucleus. Hydrogen, carbon, and oxygen are a few examples of elements. On Blackboard you'll find a list of elements common in living organisms. I would like for you to know their chemical symbols. It's not difficult. Many are symbolized using the first letter of the name of the element. C for carbon, H for hydrogen, O for oxygen. All atoms of the same element must have the same number of protons in their nuclei. However, they may differ in the number of neutrons or electrons present. Atoms of an element that have a different number of neutrons are called isotopes. Carbon-12 is ordinary carbon. It has 6 protons and 6 neutrons. Carbon-14 is an isotope of carbon. Like all carbon atoms, it has 6 protons. Unlike normal carbon, carbon-14 has 8 neutrons. Some isotopes, including carbon-14, are radioactive. A radioactive isotope is one that is unstable. It will decay or change into a different element as subatomic particles are lost from the nucleus. The rate of decay is consistent for a given isotope. The rate is not affected by conditions such as heat and pressure. In this example, radioactive carbon-14 changes into nitrogen. Isotopes are atoms of an element that have a different number of neutrons in the nucleus. In comparison, ions are atoms of an element that have a different number of electrons. Normally, the number of electrons equals the number of protons. Ions are atoms that have gained or lost one or more electrons. In this example, a sodium atom ionizes as it loses its outermost electron. With one less electron compared to the number of protons, this ion now has a positive charge. Atoms are often bonded together to form molecules. The atoms bonded together may be the same element, for example, 2 oxygen atoms in oxygen gas. Or they can be different elements, for example, 2 hydrogen atoms and 1 oxygen found in water. This completes the first video for Chapter 2. In the next screencast, we'll look at the chemical bonds that hold molecules together.